I welcome you all to the Spark Research YouTube channel. This is Dr. V. Chandra, Assistant Professor in the Department of EC, and here is another session of this particular course, Electronic Devices. And in this session, primarily we are going to take the contents from the fourth unit of this PCB design, Electronic System and PCB Design course. Right? And before going ahead, let me tell you these contents may be helpful for your gate preparation. So if you are preparing for gate, you may connect it with the. Okay, so here is the overview of the gate syllabus. So you can check the syllabus. These are the contents for electronics devices we have covered here. Some parts are remaining, and that parts will continue to cover, and definitely we will take the some questions. Okay, so here is the syllabus for fourth unit. So if we look into the syllabus, then primarily we are going to talk about the concept of PCB, component of PCB, classification and manufacturing, layout planning, PCB block diagram, importance, mechanical and electrical design considerations, types of the boards, and then rules, like we'll see that rules for the component placement in the PCB, and then assembly processes, and finally we'll look into the examples RLRC, RLC type of the layout. So let's start the session. So here question first is that what is this PCB, and what is the structure and layer, and so let's explore the PCB. So PCB nothing is that this is a printed circuit board. So here, like if you have the one example, if you can remember, like whenever you are building some circuits, you may are using like breadboard based circuit. You may have the breadboard, and then you may try to assemble the different components, resistor, capacitor, led or whatever, right? So what is the difference, like assemble whatever you are assembling that circuits with the help of the breadboard, and like you are going to fix it using the PCB. So what is the difference here? So here major difference, like you can observe it here, that will works very properly, means since all the the components are tightly fixed, so it may not like removed easily, and it will works properly, right? So this is the advantage. So like what is the exactly now meaning? So PCB boards provides both. First of all, definitely your physical structure. No doubt it will provide the physical structure. Thereafter, mounting, right? Physical structure for mounting, so that you can mount, right? In breadboard, you are going to mount. Similarly, here the physical who will provide the physical support. So your PCB, and then holding electronic component as well as, so here you are going to hold it based on the PCB, and electrical connection. What is this electrical connection? So electrical connections which is being used, and so here electrical connections means the connections which will be provided among all the electronics components, right? So the connections, like the routing details and how the different components will be connected to each other. So this is also the one of the important techniques, right? So here the different layers, you can check it here. The top layer, that is the top solder marks, that is green color, is there. Then the ground plane you can see, then the inner trace, the and the inner you can see these layers which is being just placed to the top layer, and then bottom is bottom layer, that is copper. Below to that bottom mask, solder mask layer is there. So these are the marks, and on the top of that like schematic, like one side you are going to mount the components, another side the layers may be there, and the connections are getting provided, right? So these are the techniques, right, of this PCB. So here is the overall of the PCB. Now let's continue. So what are the components of a PCB? So the essential components, first the base, means the materials that will provide the support, which is a thin of the insulating material. It may be the rigid or the flexible, and it will also provide the conductors and components, right? And then the conductors. So conductor is very important. Why? Because apart from the base, conductor will provide the connection, right, among all the. In breadboard based also, like copper wire is there inside the breadboard to provide the connection. So here also you are going to provide the copper based connection. which is high purity of the copper materials, right? Then the base provide the mechanical support to all copper areas and attached to the copper. So these are the basic components, right? Now classification. So depends on the techniques. So first technique, like suppose number of layers, based on the number of layers, the PCB may be of either single sided, maybe of the double sided, maybe of the multi sided, right? And based on the structure, maybe rigid type of a structure, then the flexible or the combination of rigid and flexible. So in one sided PCB, only the you are going to mount the components on only one side. In double side, you are going to mount the components in both side. Multi-layer, like of course from the name itself it is clear that it will have the multi-layer. From name rigid, here you are going to use the substrate, the materials rigid one, flexible, so you are going to use some polymer type of the materials which may be flexible, right? And then the substrate material, like based on the substrate, the base material, you can also divide the PCB. So maybe the FR4 type of material, maybe the aluminum type of the material, then the Rogers PCB, ceramic PCB, these are the types. Application based also you can divide, like consumer electronics based, then the professional, automotive, industrial, these are the types. Okay, then the technology based also you can divide, like plated through hole, then surface mount technology or mixed technology. So these are the types of the classification of the PCB, right? Okay, so now manufacturing, how will manufacture the PCB? So step number one, artwork generation, right? So exactly you are going to do it with the help of the simulation. So EasyEDA is one of the simulation software. Then panel preparation, then image transfer. Image transfer, from here only we will start to fabricate the hardware, right? And before that, this is the panel preparation, that is substrate preparation, so that where you are going to transfer the image that you have created during the artwork generation, right? Then image, during the image transfer, like suppose if you got the unwanted area, then you can etch, and then further you can in order to mount the component, you can go for the drilling process, then coating process. Coating, like you can go for the to provide the connection, and then testing, you can at the end of that you can do the testing, right? So here is the steps, like drilling, artwork generation, drill size, and how exactly the image will transfer. So photographic artwork positive, the photolithography we will use, right, in order to expose, and then we will transfer the image and cleaning, inspection, then the drilling, then plating, inspection, then the screen solder mask, and the inspection and the testing. So these are the major steps. So these are the highlights here. If you wanted to go the details of these steps, you can check the relevant contents, right? So here is the manufacturing of the PCB. So design and documentation. So first thing is the design and documentation, means here you are going to create the CAD file or Gerber file. So you can do it using the one of the popular software, that is EasyEDA, but that is not limited, right? You can use some another also the software. Then the material preparation, like what type of the base materials you are going to use, inner layer imaging, and then inner layer etching process. After the transmitting the image using the photoresist, you can go to the etching process. Then inner layer AI or the cleaning process, this is also important. Layer the bonding and then drilling, so that you can go and mount the components. PTH plotted through hole, that is then the outer layer imaging, then outer layer etching, and then the solder mask application. So these are the exactly the the process to manufacture. But roughly you can say that the artwork generations, whatever you have studied, that is sufficient to manufacture the PCB. Then PCB layout planning and design block diagram. So how exactly we'll plan the layout? So here we are going to see. So basically the sensor and inputs, like some examples, temperature sensor or motion sensors, So these are the devices which will the get the inputs. You can collect the inputs with the help of these, and then you can process the information, and then you can use the memory to keep the informations. Further, you can use the Wi-Fi or LTE to communicate the information, and power management like battery PMC you can use. Finally, the actuator you can use like, or output for output purpose you can use LED, right? So these are the layout planning. So based on the type of the PCB that you are designing, based on that you can design your layout. So this is the rough PCB planning, PCB layout design, where we will keep the one sensor, the processor, the memory to communicate the information, then power management, and finally the output interface, right? So these are the rough planning. Okay, so now what are the importance? So importance is like electrical performance. Whenever we are talking about the importance of PCB, keep in your mind the breadboard based circuit, right? Breadboard based circuit, and one is your PCB. Then you can understand the importance. Otherwise, you cannot understand. So breadboard based circuit means the very loved circuit, and the performance is very poor, like that, right? So electrical performance, a well-designed PCB ensure proper signal integrity, controlled impedance, then the minimal noise, everything is in proper, right? And poor layout introduce interference, signal distortion. So you can compare it with the breadboard based, right? Reliability and durability. It have the higher reliability in compare with the breadboard based circuit. Durability is also very good. Size and compactness, size will be also lower compared to breadboard because you are going to mount the components here and there, and then you have to provide the connection. So this is relatively the compact and size will be lower. Thermal management, the heat is a major enemy of the electronics, right? So heat dissipation will be lesser because of the proper connection and the placement, proper placement. Manufacturability is also easy, right? Because you are going to manufacture the PCB, so everything will have the better, the so that is why we are trying to use the PCB instead of the breadboard based circuit. So these are the advantage. Okay, then mechanical design of the PCB. So here is the mechanical design considerations. What are that? Point number one, optimal board size compatible with the PCB manufacture process. Okay. Then the position of the board, mounting holes, brackets, clamps, clip, and shielding boxes and heat sinks. Then proper fixation arrangement for heavy components, proper hole diameter it requires, right? Then type of installation of board, method of cooling, everything will matter, right? So mechanical design means simply you have to choose the very the proper size of the board. Optimal size means you cannot keep it bigger size, and then position of the board mounting should be proper, then the position size of the hole and the gap in between the the two mounting components, everything should be proper. So these are comes under the mechanical design of the PCB. So where will you fix the ground, where will you fix the components, and like all these things, right? Then types of boards, already we have gone through that based on the layers, so single, double, multi-layers, and based on the materials, maybe the rigid, flexible, all these, right? Now mounting techniques. So what are the major mounting techniques? So mounting, here you can see that mounting techniques refer to how electronic components are attached to the PCB, right? So from the technology point of view, you can throw whole technology, you can that is called THT, then surface mount technology. This is also one of the important one. Then soldering method, like we'll have the reflow soldering method like SMT, then wave soldering, then hand soldering. You can do it, right? And by the mounting orientation also, like vertical orientation or the horizontal orientation or angle. So depending on the scenario, you can the fix the your count components. in vertical or horizontal. It depends. So these are the techniques, right? Then coming to the analysis, stress analysis in PCB design. So what are the things here? Actually, whenever we are designing the PCB, the point is that whether will it sustain the pressure or not. So force whatever the exerting. So that is comes under the stress analysis. So here is the simulation one, like suppose your PCB is there and if you are putting the some force over it, then what will happen? Your PCB should not broken, right? So how much stress it can suffer? So mechanical vibration and the boundary conditions, these are, and what how much shock it can sustain. So these other things are important here. Not only the mechanical vibration, but also the thermal management, how much temperature variation it can sustain your PCB. So these are the things are important to while we are designing the PCB. Okay. So what is the PCB stress test analysis? So PCB stress testing is the evaluation of the circuit board ability withstand or endure forces or parameter strain. Comparatively, a small PCB with a size of less than 100 into 150 millimeter, the standard thickness of the 1.6 mm will hardly pose any problem in mechanical strength. Okay, so care is needed with the bigger size, otherwise it will be broken with the much the high stress. Our gentle guidelines happy parts should be the mounted near a supportive device like a card guide connected to a shifter. Then electrical design consideration of PCB here. So power distribution and the grounding, where will you put the grounding so that it will be distribute the power, signal integrity. So keep the traces short and direct, avoid the sharp angles and the stubs, right? And then the impedance control, noise and error, EMI control, crosstalk reduction, thermal management. These are the the important electrical design consideration. Okay, is protection, then the testability, design, and the reliability. All these things. Then the rules for component placement. So there are the some rules. You cannot randomly the mount any components. You cannot fix any components here, right? So logical and functional. So to keep all these type of components, you can keep it at one place, and group by functional by minimizing the signal interference. So you can make a group of digital components. You can make a group of power separately, analog, and this like so group make a group of all the components, related components, right? Then the manufacturing DFM and the efficiency. So orientation will matters with the standard ICPC components polarity for standard PNP flow. Similarly, physical and mechanical constant keep out zones and the chassis mounted hole. So you can fix it at one point so that the heavy components place large heavy parts near fixed mounting points to prevent the board flags. Otherwise, it may broken, right? So signal integrity and high speed design. So decoupling caps, place decoupling capacitor close to the IC power pins to reduce the parasitic capacitance. So these are the some general rules. Then there is some rules for providing the power supply on the board. What are that? So design for power supply planes, like large planes reduce the inductance, then dedicated layers for stability, and so separate noise circuits. So you can have the power area for high current and digital area for high speed, and analog area for sensitive, right? And proper ground connection, not only power but ground also will matters. And why is it so? Plane layer connection, so maxima is via connectivity decrease resistance. So plane layer connection is here, component pin and thermal pad wire. Okay, so these are the important. So here is the connection layout now. So PCB layout defines the final physical form of the circuits and includes the labeling, Details of the equipments can then be finalized as the layout of the completed. So layout, that is well planning, that we have already discussed. You can go through that. We'll draw a schematic and minimum number of the crossover and the loops, right? It should not cross, otherwise it will be the difficult to design the circuit itself, and also the function may be the improper, and the number and the position of the external connection to be used with the interconnection system, as this play an important role in determining the position of input, output, and ground terminations. Interference or noise from the decoupling. So these are the points that you are going to keep in mind while planning, right? Also, the general conditions for the good layout are what are that expected production volume. So you can keep inside the brain then assembly facilities and technologies, along with the desirable degree of the automation, transportation arrangement, heat removal considerations. All these things will matter on your connection layout. Finally, your assembly process. So here is the following steps: the components collection as per the specification given in the bill of materials, preparation of the components or components forming, PCB cleaning, washing with the commercial cleaners or raising in the water, then inspection of the boards and components of the dimensions, component insertion, soldering of components lead by hand, soldering by using a mass soldering machine. So here is the PCB layout design explaining some RL, RC and RSA circuits. So these are the examples. So here is the RL circuit. You can see here we are going to fix the R and L type of the components, and in order to minimize the trace length, so we will keep it closer to each other, and the likewise you can see the RC type of the circuits, we are going to mount it here, and RLC type of the circuits. Okay, thank you to join the session. If you have any doubts, you may drop your comments.